Thank you. Yes, that's exactly what I'm going to be talking about. In the last 50 years, raw material extraction and use in the world has tripled, like the annual. And the United Nations Environmental Programme already in 2011 said that we need to decouple natural resource use and environmental impacts from economic growth. The circular economy is not a goal in itself, but it's a means to an end. It's a systemic, it's a transformation of the entire system. We need to reduce our material use, we need to recycle the material use, we need to repair and reuse, and we need to redesign. It's basically the same four things that Jasper said this morning and that came up in all the presentations today. And all the presentations I've seen today already had a really comprehensive understanding of the value chain and of the importance of the entire value chain upstream as well as downstream of the production. So this picture is not really new. Everyone here knows it. It's the circular economy. So the technological advances for a more circular economy can occur at any point in the value chain. For example, in the processing industry, something might happen that might make it more efficient and reduce material inputs. That has effects on the resources that are used, on the emissions, because probably you need less energy if you have a more efficient process, but also on the jobs. Maybe it's more high-skilled jobs that are needed for this process, but it's fewer jobs, fewer people that are employed. But if you reduce your material inputs, you also extract less materials. So upstream, you'll have less resource extraction, less emissions, but also you might have fewer jobs. That's the second key aspect is recycling. If we have a more efficient recycling industry, the aluminum example this morning was really, really good, then we don't at all need to extract raw materials, aluminum ores at all. So all the jobs in the aluminum mining industry will be lost. But also, the emissions will be avoided. And so on. So in the manufacturing, we can have better design, or we can have more of a sharing, a reuse and repair economy that's reducing material use, reducing emissions, but maybe also reducing jobs. And we just heard about the improved waste collection system. It's the same story all over again. And then we always need to look at what happens outside the country. Norway is a small country, but it's very well integrated into global markets. And we've already heard that before. The example Jasper mentioned now is it's very true that a lot of the biomass coming for the biodiesel and use in Europe is coming from the Amazon. But it's a lot of biodiversity loss and loss of land for producing food if Europe would have switched completely to biodiesel, but they did stop that. Even though Norway has quite a bit of raw materials itself and a really well-developed processing industry, it's not completely independent of raw material inputs. And that's true, even more true for most other countries in the world. So the OECD expects that raw materials use is to double until 2060 from now. And the policy conclusions are that no country is really self-sufficient in key raw materials, so every country needs to look out where the materials come from. The raw material extraction countries, they cannot keep the jobs. That was the last point. Oh, sorry. Export restrictions are not the best way to support or create a downstream processing industry. Norway has successfully created processing industries, but other countries have not done that successfully. So the aim doing an analysis of global sustainability effects of technological advances towards a more circular economy is to identify the effects on economy, society, and environment that occur in other countries as well, not only in the original country. Of course, also domestically. And the scope is to analyze impacts or effects along upstream and downstream value chains, like within the country and abroad, so cross-border effects, and also within the industry and in other industries as well. And we'll always look at the 3 pillars of sustainable development: the economic, so value creation, and social effects, employment, and well, everything that's related with employment, like income and education. And then, of course, environmental issues like emissions to or resource extraction from the natural environment. So, questions to ask yourself is, if we do this analysis, the technological change and what might happen to global value chains, is what's new compared to the incumbent technology? Is it a changed production structure? Is it just a marginal improvement over the old product? Or is it a completely new technology replacing the old technology? What are the most important differences in the input structure of the technology production? Using wind or producing windmills requires a completely different production inputs than coal power plants, for example. So which industries or countries produce the old intermediate inputs, and which industries or countries produce the new inputs into the technology? How important is that new component, like the raw material itself, or the individual component for the global market? Or is it only affecting a certain industry in a certain country? Once China entered the market for solar panels a few years ago, a whole region in Germany almost went bankrupt because all the solar panel producing businesses went to China. Or they went out of business because the Chinese could produce it cheaper. And what are the most important differences occurring through the use of the new technology? So that what's the downstream impacts of the new technology on the employment opportunities as well as the environmental impacts? So there exists a variety of system-wide analysis tools. We've already heard LCA today. There's also LCI. Like the impact assessment, what actually happens to biodiversity, what's the global warming potential. And there's material flow analysis, and Helen will talk about that in the next presentation. I'll focus on multi-regional input-output analysis, which is a macroeconomic tool. And input-output tables has anyone ever heard input-output tables here? Input-output analysis? A few, very few. Okay, it's always represented in matrix form. I love matrices. Probably a lot of you are scared of it, so I won't ask anything about it. These tables are produced by national statistical offices, and they give a detailed snapshot of the entire economy. So how much does the processing industry produce in Norway? How much does the mining industry? Some secrets there. How much does agriculture produce, and so on. And they are consistent with the system of national accounting. And they show, in the medium part of the matrix, what kind of inputs all the industries, for example, agriculture uses from the plastics industry, or how much other manufacturing, that's where food production is, how much the food industry uses from agriculture inputs, and so on. And they also show down here how many people are employed, how much salaries are paid, and how much capital inputs are needed in all of the industries. And they show what kind of products households, government, and firms, it's investment goods, what kind of products they demand. And then we have some environmental extensions to these tables, where we see how much emissions are produced in all of these industries. And using my favorite equation here. I'm not going to ask about it again. We can actually calculate not only the direct effects of a change in one of the industries, but also the indirect effect that happens due to a change in one industry, and then it just trickles down through the entire economy to all other industries. I'll give you an example later. This type of analysis has increasingly been used in global value chain analysis, where these tables that I just showed you, they have been connected with international trade data to connect all the industries in the world with each other. So how much inputs is the German coal industry for producing electricity using from the Australian coal sector? And one of there are two main drivers for this rather academic development of analysis. One was the OECD and World Trade Organization Trade and Value Added Initiative, showing that the value added content, so the value content in a product that's produced in a country, it's a lot less than the actual value of the export good. And then the other part was environmental footprints of countries. So environmental product footprints, I think all of you have heard of, but can be used to calculate the environmental footprints of entire countries. And this graph just shows the share of CO2 emitted abroad in the total CO2 embedded in domestic final demand. And for small countries, European countries like Luxembourg, Switzerland, or Norway, 70% of the carbon that was emitted during the production of our consumer goods was actually emitted abroad. Mostly in blue in OECD countries, but for Norway it was actually a lot emitted in non-OECD countries like China. There is a limitation of using this macroeconomic approach, because I've just been talking about whole industries, like the agricultural industry or the mining industry or the processing industry. It's not very product specific. And we're missing data in the global databases of developing countries that are very rich in resources like Congo, like cobalt production in Congo. But we can use this global value chain thinking for individual technologies as well, by explicitly considering this bilateral trade with individual countries in our upstream value chains. And this would complement other value chain analysis tools, for example, like LCA. There is a lot of hybrid LCA already going on, but there's no explicit consideration of international trade in that analysis yet. So, going from a micro technological advance to the global impact, we just look at, are we replacing one input by another? Are we reducing material inputs? And then we can look at very, very detailed global trade data. I'll show you an example of that on the next slide. So this was an EU project that SINTEF was part of. And they've developed they've improved the material use in a solar panel. And for example, it uses about 5% of the aluminum, an original multi-crystalline panel with 60 solar cells is using. And they're using, instead of 1.5 kilograms of silicon, only 1 kilogram of silicon to produce this panel. So with this newly developed solar cell, the number of solar panels that can be produced with the same amount of silicon as before is 40% more. And related, we have 30% less environmental pressures. So this is the Comtrade database. So it has silicon containing by weight not less than 99.99% of silicon. I think there's some engineers here that are way better in understanding this than I am. And this is where Norway gets its imports from. It's a lot of kilograms, so we could produce a lot of solar panels, but I think it's used in a lot of other different technologies as well. So the Norway's imports for production of solar panels has a very, very low importance for global markets. That was one of the questions that I asked earlier. But we can still reduce the upstream inputs. Downstream, it can be recycled and reused, because this was one of the big outcomes of this, this research project, that all the components on the panel should be reusable. And then, again, we can reuse it, and we can have even more reduction of raw material inputs. But yeah, as I said, it might be low importance for global markets in this case, but just imagine a 40 or like a 30% reduction, what it would make with the lithium in Chile. Chile is Chile, Bolivia, that region has the largest lithium resources in the world. And this is how it looks when it's produced there. And this is how beautiful it was before. So if we could lessen the environmental pressures, that would be great. Or the same with cobalt in Congo. And there it would not only lessen environmental pressures, but also it would lessen employment, but it will also lessen very, very dangerous employment, and they could probably just grow food. So the next example is where I'm going to show you the matrix again. Because when producing plastics, we are going to replace oil by biomass, by agricultural and forestry inputs. And then the agricultural and the forestry industry would produce more, and the oil mining industry would produce less. And so we would extract fewer abiotic materials, we would extract more biotic materials, and I should have made a green one here, because we will have more emissions from agricultural production, but we'll have less emissions from oil production. 8% of global oil is used for plastics. So then we can use the oil for other things. Not sure we should do that, but that's something to think about. And then if we increase the use of biomass, we'll have more pollution from fertilizers. We've heard that before already today. But another interesting thing that I found from the European Bioplastics Organization is that the food, feed, fuel discussion will not necessarily be food, feed, fuel plastics, because at least right now, the amount of bioplastics in total biomass production is very, very low. But we still need to keep that in mind, that that might happen. Now, because I've been talking a lot about cross-border effects, producing bioplastic compared to conventional plastic would actually spread the positive effects more around the world, because biomass can be produced in a lot of countries, so there would be a huge employment effect. Also, agricultural production is usually more employment intensive. More people are needed, more people will need a job, while the mining or oil mining industry is less employment intense, and it's very, very concentrated in a few countries. So here we all again have global value chain changes upstream and downstream because of all the pollution. And if we have bioplastics, there are some other technologies going on, and if we combine it with a new collection system, as we've just heard, we might have fewer environmental impacts. So the results of this type of analysis can be used by industries, like industry associations, or individual companies as well. But the most important thing is that we all need to be aware of non-cost related impacts outside the direct supply chain, because it can always trickle down to other industries in other countries. And with this type of analysis, we can link the company's actions to the global environmental pressures. And, well, you know that we can reduce dependencies on raw materials. There was a lot of talking about high costs today. And I think we just need to wait a little more to have the technologies develop further to reduce costs. I need to stop talking. For policy, it's the same basic use in the end. It's like consider environmental impacts outside national borders and distribute employment effects around the world, decreasing import dependencies. Yes, these are my takeaway messages, but I might get a question on those anyway later. So indirect effects on society and environment should always be estimated to avoid potential negative implications of a technology that's supposed to be good. And we always need to see what upscaling that technology means in the global shift towards a more circular economy. And if we actually do this global upscaling, international raw material markets might be affected to a large degree. One can be that there are shortages of the material occurring, and the other one might be that the raw material extraction countries might suffer. Thank you.
All right.